Hello guys, and welcome to another video. Okay, so in this video we're trying to solve questions on current division and then voltage drop. Okay, so this tutorial will be on current division and then voltage drop. So in case you are new here, kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Okay, so let's dive right into this video. Okay, now when we talk about current division and voltage drop, we are trying to find a current passing through a specific resistor. Okay, and then maybe whenever you've been given or you've not been given certain voltages, you use the Ohm's law to find your voltage and maybe your current, right? Now let's dive right into this video. Now, so from here you can notice that we have a certain circuit with a short circuit. Okay, so AB, okay, is a short circuit. So from our previous tutorial, you got to know that short circuits prevent current from flowing across them. Okay, so they just absorb all current flowing towards them. Okay, meaning that they prevent the current from flowing towards other resistances. Okay, so now from here, listen to this attentively. Okay, you might meet this in your exams or test or whatever. Okay, since Y, A and B is a short circuit, okay, it means that no current will flow through this portion. Okay, so no current, so the current will start from this portion. Okay, so 7 volts, the current will move in this direction. Okay, and then maybe this direction. Okay, but once the current gets to this point, all the current will be absorbed through the YAP. Okay, so no current will flow to the Y, where we have our resistor 4 ohm. Okay, now since this 4 ohm resistor and then this 2 ohm resistor are in parallel, okay, once this 4 ohm resistor has been short circuited, it means that since it's in parallel with this 2 ohm resistor, this means that this 2 ohm resistor won't be considered. Okay, so this 4 ohm resistor will be short circuited, and then this 4 ohm resistor is in parallel with this 2 ohm resistor. It means that this 2 ohm resistor will not be considered. So we have 4 ohm resistor being short circuited. Okay, it's being short circuited. Okay, so since the 4 ohm resistor has been short circuited, that will also affect this 2 ohm resistor because the 4 ohm and the 2 ohm are in parallel. Okay, so 4 ohm and then 2 ohm will not be considered. Okay, they won't be considered, not considered. Pay rapt attention to this portion, okay, because you might meet similar question. Okay, so again listen attentively. There is a short circuit. Okay, AB is a short circuit, and then we know that short circuit absorb all current flowing towards them. Okay, it means that no current will flow through this 4 ohm resistor. It means that this 4 ohm resistor has been short circuited. Now this 4 ohm resistor is in parallel with this 2 ohm resistor, and then once this 4 ohm resistor is in parallel with this 2 ohm resistor, it simply means that this 2 ohm resistor will not be considered because the 4 ohm resistor has been short circuited, hence affecting the parallelity. Or since the 4 ohm and then the 2 ohm are in parallel, it means that the 2 ohm will also be affected since the 4 ohm has been short circuited. Okay, it means that our general circuit will be in this form. Okay, right, so we have 7 volts. Okay, and then we have 5 ohm. Okay, and then 7 volts. So this is how our general circuit will be reduced to. Okay, so now let's find the current passing through this. Yes, let's say these are currents. So these are simple Ohm's law. Okay, you know that V equals IR. Okay, so let's find what I. We have what V on what R. Okay, we have what 7 on what 5. Okay, this will be the same as what 1.4 amps. Okay, so the reason why I'm making these tutorial videos is that I specifically choose questions which are what tricky. Okay, so that you get to understand the various twists and turns in what calculations. Okay, so from here someone might think that since this is a short circuit, 4 ohm has been short circuited, it means that you'll be left with what 2 ohm and then 5 ohm. Okay, and then with maybe 7 volts, and then they go ahead with the calculation, end up with what a wrong answer. Okay, now let's proceed to our second question. Okay, now from here we could notice that we don't have any what short circuit or any of that sort. Okay, so now right, so we have what a certain 2 ohm, 1 ohm, and then 4 ohm. Now from here you could notice that 1 ohm and then 4 ohm are in what parallel. That's right, because when you traverse through the 1 ohm and 4 ohm, there is no other element. Okay, so we have what the 1 ohm, okay, being parallel with what the 4 ohm. Okay, so we have what 1 times 4 divided by what 1 plus what 4, giving us what we have 4.5 ohm. That's equal to, say, let's simplify this as what 4.5 ohm. Okay, now, or simply put 0.8 ohm. Okay, so now let's proceed. So let's redraw this circuit. So we have what this, okay, coming in, okay, and then we have what that's coming in. Okay, so we have 2 ohm, okay, and then we have what 20 watts amps. Okay, so from here we know that this is our I1, okay, and then this is our I2. So we can just implement what current division rule. Okay, so note that the first question we are just finding what just current. Okay, but for the second question we have to what employ what current division rule. Okay, and then the reason why we got to simplify this question was that we had what a short circuit. Okay, so now let's proceed. Okay, so using what our current division rule from this circuit. Okay, so using current division rule or current divider rule. Okay, division rule. Okay, using current division rule, we have what these are I2. Okay, these are 20 ohm 20 amperes. Okay, so in case you want to find what current I2, you know the current division rule. Okay, you know the formula. So we have what I2 equals what this resistor. Okay, so you have 2 divided by the sum of the 2 resistors. Okay, you have 2 plus what 0.8. okay, and then you multiply that by what your 20 amps. Okay, so this will give us what, when you compute this, you end up with what 14.2 maybe 86 amps. Okay, right, so we know that what I2 is what 14.286 amps. So let's proceed now. So from here we could notice that we found what I2, okay, but we haven't found what I1, right? So this is what we've been able to calculate, I2. Let's try find what I3. Okay, let's try find I3. So in order to find I3, listen attentively. Okay, that's why I stated initially that I tried to pick tricky questions and then solve with you so that you know the twists and turns. Okay, in order to find I3, you need to find I3 so that you can find what I2. Okay, so now let's proceed. In order to find I3, this is how we redraw a circuit. Okay, so we have what, so we in order to find I3, we begin from what where we have I2, okay. So this is how you draw a circuit where we have what this coming in, okay, with what this resistor, okay, and then we have this resistor, okay. So from here you can notice that I'm redrawing this portion of the circuit, okay, because I want to find what I3, okay. So we have what 4 ohms, okay, and then we have what 1 ohm, okay. Note that I'm redrawing this portion of the circuit because I want to find what I3, okay. So this is my I3, okay, and then we have what a certain 14.286 amps, okay. So note that the same current will pass through here, okay. So this is our I2, okay. So from here we add the I2 to be here, okay. Now, so let's say we have what, okay, so let's say we have maybe I3 over here, okay, and let's say we have I4 over here, okay. So let's put it in that format, okay. So this will be our I4, and let's find what I3, okay. So this is what, let's say this I4, we are finding what I3 because these are what I2, okay. Yes, try to understand these questions because they are specifically picked so that you get to understand certain twists and turns in what some calculations, okay. So now from here we go to what reduce this circuit into this format, and then we calculated for I2, okay, and then we are now coming back to this circuit, okay, to calculate for I3, okay, current I3. Now this is how you calculate for maybe current I3, but you just presume that what we are calculating for I3, but for here the current I3 will flow through what 4 ohms, okay. But when you reduce the circuit, you can notice that the current I3 is flowing through what the 1 ohm, okay. So now let's proceed. So in order to find out your I3, okay, using the current divider rule, okay, using the current divider rule, okay, the CDR, okay. So we have what, we have 4, okay, divided by what, we are finding this, so we use this one, okay. I3, so we have 4 on what 1 plus 4, okay, 1 plus 4, okay, and then multiply by what I2, which was what 14.286, okay. So we have what I3 to be equal to when you do the computation, you end up with maybe 11.428 amps, okay, 11.428 amps, okay. So now we want to now find what the main current passing through what I1, okay. That's how you find what your main current passing through I1, okay. So the main question is what to find what, sorry I didn't state that, the main question is to find what the current passing through this 2 ohm resistor, okay, this 2 ohm resistor, right. So that's how we got to know, do our main calculation. Now let's find that current, okay. Okay, so after calculating the current passing through the I3, okay, that's our 1 ohm resistor. So first we got to calculate the current passing through what, sorry, the current passing through what I2, okay. We got to calculate I2, and then we got to also calculate what I1, okay, the current passing through I1, okay. So I think this brings us to the end of this tutorial, okay. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video. Like the video so that it gets pushed to other students who might need this video, okay, to enhance their studies. Ask your questions in the comment section, and then I'll also reply to them as soon as possible. And I will see you in the next video. Bye bye.